Okay, what we're going to do in this video, we're going to do it pretty quickly, is we're going to do surface areas of cones and spheres. So I don't think we have any trouble with it. You've done these before, so I'm just going to share the PowerPoint with you and just kind of talk you through it for just a second. We're going to start out working with cones. Now, I don't really have a cone with me, but you know what a cone looks like. It basically is like a sugar cone when you're eating ice cream. So you've got a circle, and then you've got the area around the top part. Now, your formula, you have to kind of start learning it. Now, the good thing is you'll have your notes in your book when you're taking your test, but not when you take your practice test. So I do want you to just kind of start learning them. There's only one circle on a cone, so that's why there's only one pi r squared. Now, remember when you had a cylinder, you had a circle on the top and a circle on the bottom, so that's why there's two of them. But with the cone, you've only got one pi r squared. And then you got this pi r l. You can read in your book, and they kind of explain where that pi r l comes from. But basically, it's if you were to talk about the white paper on the outside of a paper cone, that's the pi r l. So that r is your radius. Now this L is something called slant length. So this slant height right here, from right here at the top down the side, that's that L. It's that slant length. Now height is straight up and down. We'll need it when we do volume in a little bit, but not today. So that height, but we're talking about this slant length. So that's the formula that we're going to use. So let's go work just a couple of examples to make sure that everybody's good. I don't foresee a problem at all. So here's my formula, that pi r squared plus pi r l. So I'm going to clear that notation so it doesn't distract you, hopefully. So do we understand that this 13 from tip down, slanted length down to the side, that's my L. So that's why that 13 went in for that L. Then I need my radius. Well, it shows you your radius is 5 meters. So 5 goes in for that R and 5 goes in for that R. Order of operations, we don't have anything inside of a parenthesis to do, but we do have exponents. So I'm going to need to square that 5. That's where I got 25. And when you square meters, you get square meters. So that's where I got that 25 pi square meters here, and then 5 times the 13 is 65, so that's how I got 65 square meters here. And so I got 25 pi square meters plus 65 pi square meters is 90 pi square meters. When you add pi's to pi's, you get pi's. When you add square meters to square meters, you get square meters. So that's why I get this exact answer, or you can give me a decimal approximation if you prefer. So when you put that 3 and 1400ths in there, though, remember that equals has to turn to approximately equal to, or I'm going to count off. So I wouldn't care on a test whether you gave me the exact answer with an equals or whether you gave me an approximation, as long as you put approximately equal to. And then down here, I kind of show you what I'm talking about, like we did before. You can think about it like when you took algebra, when you factored things out. I could factor out a pi, and that would leave me this parenthesis first, and 25 plus 65 is 90. So that's why 25 plus 65 pi is 90 pi. Okay, so let's go look at one more. Just it has a little bit more to it. Not much. It's super simple. I don't think you're going to have any trouble. But what if something you need is missing? Let's go make sure we'd be okay finding it. Same formula, pi r squared plus pi r l. My radius is 2. So that r went in for 2 right here, and that r went in for 2 right there. But I'm missing something. I'm missing my slant length. See, this 8 is this height, but I need this L right here, from here down the side, and I'm missing it. But I notice that I've got a right triangle in here, so I'm going to use Pythagorean theorem to find this side right here. Now, this side that's missing is right across from the right angle. Remember, that's called your hypotenuse. So remember, Pythagorean theorem says a leg squared plus a leg squared is the hypotenuse squared. Well, one of my legs is 2. There's 1. My other leg is 8. And then I'm missing my slant length. Well, when you square 8, you get 64. When you square 2, you get 4. So my L squared is 68. Not L, but L squared. So I've got to take the square root of both sides. Now, we did this in Math 210. If you did a factor tree for 68, you'd get 2 times 2 times 17. So when you circled that pair of 2s and you brought that pair out, remember you write what's in the circle one time. So that's why I got 2 to the square root of 17 right here for my length. And that's where I get the 4 pi. And then 2 times 2 is 4. And I've still got that square root of 17 pi. So you don't say that you have 8 to the square root of 17. It's just 4 plus 4 to the square root of 17 pi. That's as simplified as I can make that. So really here, for most elementary people, the decimal approximation is a little better. So I did a 3 1400 for pi, and then I'd used my calculator and got a decimal approximation for the square root of 17. So you could give me an exact answer like this one, or a decimal approximation like that one. I would be good either way. So all you really need to know to find the surface area of a cone is the radius and that slant length. And then you substitute into your formulas. Now, what about a sphere? Now, let me tell you what I would normally do and kind of where it comes from when we're doing a sphere. Now, you know, a sphere is like a ball. What I would have you do in a regular class is bring into class an orange, like you eat, like a navel orange. And I would tell you to take your compass and try to draw a circle that's about the same size as this equator. And then I'd want you to peel your orange, because remember, the peeling would be the surface area, the outside of your sphere. And see how many circles it would take for this peeling to fill. So I usually tell you to draw 3 or 4 or 5 of those equator circles, and then peel your orange and see how many circles it would take for you to use the peeling and fill them in. And what you find out is this: if that were exactly a sphere, and remember, you know, it's not going to be exactly a sphere, maybe a little lopsided. So what would end up happening, let me clear these drawings, okay? It would take exactly 4 of those equator circles. Then your peeling would fill up 4 whole circles, and there'd be none left over. So the surface area for one for a sphere is 4 circles. So all you really know is your radius. So when you know your radius, all right, so if I knew from here to here was a 9, all right, if I knew that radius was 9, I would square my 9 and get 36, and then 36 times 4 would be 324. And again, I'd have pi, okay? A decimal approximation. Now, I would need to put, remember, my inches, and then make sure that they're squared. So you'd make, you know, you'd have to have your square inches. Surface area is always square units. So you could give me an exact answer or a decimal approximation. I would be okay with either one of those. So let's go look at an example. Okay. Here we go. Now this one, instead of giving you the radius, I gave you the diameter, because sometimes they'll do that. But you know, you're smart. You know how to do this. Easy, easy peasy. If it's 8 all the way across the circle on the diameter, remember the radius is going to be half of that. So you would know the radius is 4. Since the diameter is 8, the radius is half of that. Well, you have to square your 4 and get 16, and then 16 times 4 is 64, and don't lose that pi. So 64 pi, if you substitute 3 1400ths for that pi, then make sure you put 296 hundredths. Either way, I've got to have square centimeters, because surface area is square units. So that's a cone and a sphere, super easy. I don't think you're going to have any trouble with it. All right, so let's stop that screen. Try that homework. If you have any trouble, then get back with me, okay?